Dear students, do you want to get into the fascinating world of physics? Please see this video and also subscribe to this channel.
Have you ever wondered how your cell phone gets a signal, or how light travels from the sun to the earth? It's all thanks to the incredible phenomenon of electromagnetic, or EM, waves. Today we're diving into the production and properties of EM waves. Let's get started.
Dear students, we are now going to study about the electromagnetic waves and also about the production of these electromagnetic waves and its properties. Sources of electromagnetic waves, how they are classified. Let us first think about the famous scientist Heinrich Rudolf Hertz, who produced these electromagnetic waves by this arrangement, which is shown by this schematic diagram of Hertz apparatus, in which there are a transmitter and a receiver. Here this transmitter is actually transmits the electromagnetic waves which are received by the receiver, which is kept at a distance from the transmitter. So first let us study about what are electromagnetic waves. These electromagnetic waves are non-mechanical waves which move with the speed which is equal to the speed of light in vacuum. And as you know that light has transverse wave nature, and similar to that the electromagnetic waves are also transverse in nature. So we are going to discuss about the production of electromagnetic waves and its properties, and sources of electromagnetic waves, and also classification of electromagnetic spectrum. Now, the first case, let us study about the production and properties of electromagnetic waves. And these electromagnetic waves are produced by Hertz experiment. And this Maxwell's prediction of electromagnetic waves that was experimentally confirmed by Heinrich Rudolf Hertz in 1888. And the experimental setup is used which is as shown in this diagram. There will be an induction coil, and there is a transmitter which transmits the electromagnetic waves, and these electromagnetic waves are received by a receiver. So this is a schematic diagram of Hertz apparatus, and this consists of two metal electrodes which are made up of small spherical metals. These are connected to large spheres. The ends of them are connected to an induction coil, very large number of turns, which is actually used to produce very high electromotive force. And since the coil is maintained at very high potential, air between the electrodes gets ionized and spark will be produced. That spark is due to discharge of electricity, and this discharge of electricity affects another electrode which is a ring-shaped type, which is not completely closed, and that is kept at far distance. This implies that the energy is transmitted from the electrode to the receiver, that is from the transmitter to the receiver, and this receiver is a ring electrode in the form of waves. This energy will be transmitted, and those waves they are called as electromagnetic waves. And if the receiver is rotated by 90 degrees, then no spark is observed by the receiver. That confirms the electromagnetic waves are transverse in nature as predicted by Maxwell. And Hertz also detected radio waves and also computed the speed of radio waves, and that is equal to that of speed of light, that is given between 10 to 8 meters per second. And we should also note that this LC oscillator circuit with proper setup can be used to generate radio waves whose frequency is the same as the frequency of the LC oscillations, which is given by F is equal to 1 by 2 pi root of LC Hertz. Now let us study about the properties of electromagnetic waves. These electromagnetic waves are produced by any accelerated charge. The electromagnetic waves do not require any medium of propagation. That means that the electromagnetic wave is a non-mechanical wave. The electromagnetic waves are transverse in nature. The oscillating electric field vector, oscillating magnetic field vector, and propagation vector, which gives the direction of propagation, are all mutually perpendicular to each other, as shown in this diagram. So here this E represents the electric field, which is on this side, and this B represents the magnetic field, which is perpendicular to that of the electric field. And these two fields, which are electric field and magnetic field, they are actually mutually perpendicular to the direction of propagation of these electromagnetic waves. So if electric and magnetic fields are as shown in this diagram, then the direction of propagation will be along the x direction. And the next point is electromagnetic waves travel with the speed which is equal to the speed of light in vacuum or free space. The c is given by 1 by root of epsilon naught mu naught, and that's given by 3 in 10 power 8 meter per second. That is, epsilon naught is the permittivity of free space or vacuum, and mu naught is the permeability of free space or vacuum. The next one is in a medium with permittivity epsilon and permeability mu, the speed of electromagnetic wave is less than that in free space or vacuum, which means V is less than C. So in a medium of refractive index n is equal to C by V, the expression can be written as n is equal to root of epsilon r into mu r by simplifying this. Here epsilon r is called the relative permittivity of a medium, which is also known as the dielectric constant, and mu r is the relative permeability of the medium. Electromagnetic waves are not deflected by electric field or magnetic field. Electromagnetic waves can exhibit interference, diffraction, and also polarization. Like other waves, these electromagnetic waves also carry energy, linear momentum, and angular momentum. Then, if the electromagnetic wave incident on a material surface is completely absorbed, then the energy delivered is given by the expression U, and momentum imparted on the surface is given by P equal to U by C. Next point, the last one. If the incident electromagnetic wave of energy U is totally reflected from the surface, then the momentum delivered to the surface is given by this expression delta P equal to U by C minus of minus U by C, that's given by 2U by C.